Today we discuss on the largest eigenvalue problem. Actually, largest eigenvalue means here the numerically largest eigenvalue problem by power method. And lastly, we discuss the computer C programming for this power method to find the largest eigenvalue of a square matrix. Now, the theory for this power method to calculate numerically largest eigenvalue of a real square matrix of order n. When does this method fail? Suppose here the power method is a simple iterative method to find the dominant or the largest eigenvalue in magnitude numerically, and the corresponding eigenvector of a real square matrix of order n, and let capital A be a square matrix of order n, and lambda 1, lambda 2, lambda n are eigenvalues of that matrix A. Suppose that modulus of lambda 1 is greater than modulus of lambda 2, greater than equal to modulus of lambda 3, and so on greater than equal to modulus of lambda n. Here notice that modulus of lambda n, at least one of the eigenvalue numerically largest from the other eigenvalues. So here notice that here lambda 1, modulus of lambda 1 is greater than modulus of lambda 2, but other eigenvalues may be equal, say lambda 2 modulus of lambda 2 greater than equal to, and greater than equal to, and but modulus of lambda 1 is the numerically largest eigenvalue. Here we assume this, and capital X1, capital X2, and capital Xn be the corresponding linearly independent eigenvectors. Corresponding means capital X1 is the eigenvector corresponding to lambda 1, capital X2 is the eigenvector corresponding to lambda 2, and so on. The procedure is applicable if a complete system of n independent eigenvectors exist, even though some of the eigenvalues lambda 2, lambda 3, and lambda n may not be distinct. Then this case arises from lambda 2 equal to lambda 3 numerically equal, modulus of lambda 2 equal to modulus of lambda 3 and equal to modulus of lambda n, and so on. Here note that there are n independent eigenvectors exist. This is the most important condition for this. Then any eigenvector capital X0 is the space of eigenvectors, vector space capital X1, capital X2, capital Xn, can be written as this capital X1 is a linear combination of the other eigenvectors C1 capital X1, C2 capital X2 plus plus Cn capital Xn, where Ci's are the constant with C1 not equal to 0, corresponding to numerically largest eigen values, and corresponding to capital X1 is the corresponding to numerically largest eigenvalues corresponding eigenvector. From the definition of eigenvector, we know that A capital Xi equal to lambda xi for I is equal to 1 to n, A xi equal to lambda I xi. So ax1 equal to lambda 1 x1, ax2 equal to lambda 2 x2, and so on. Pre-multiplying by a on both sides of 1. Suppose this is the equation 1, capital X0 C1 x1 C2 x2 plus Cn xn is the equation 1. Pre-multiplying from the left side, that means from the left side, ax0 equal to C1 is constant, so ax1 plus C2 ax2 plus Cn axn. Now from the equation 2, ax1 means lambda 1 x1, ax2 means lambda 2 x2. So we can write this C1 lambda 1 x1, C2 lambda 2 x2, Cn lambda n xn. Again pre-multiplying by the matrix A, we get this A square x0 equal to C1 lambda 1 ax1, C2 lambda 2 ax2 plus dot Cn lambda n axn. So we put here the ax1 equal to lambda 1 x1. So we can write C1 lambda 1 square x1, C2 lambda 2 square x2, and so on. And taking common lambda 1 square, and so we get lambda 1 square common into C1 capital X1 plus C2 lambda 2 by lambda 1 whole square x2 plus Cn lambda n by lambda n whole square xn. And in this way we can write again multiplying by the matrix A, pre-multiplying by the matrix A up to k times. So a to the power k x0 equal to lambda 1 to the power k C1 x1 plus C2 lambda 2 by lambda 1 to the power k x2 and plus dot 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 dot. And again pre-multiplying by the matrix A, then we get a to the power k plus 1 x0 equal to lambda 1 to the power k plus 1 C1 x1 plus C2 lambda 2 by lambda 1 k to the k plus 1 x2 plus Cn lambda n by lambda 1 to the whole to the power k plus 1 xn. Now k up to infinity, k tends to infinity means the large number of k. So this ak x0 equal to lambda 1 to the power k C1 x1 and ak plus 1 x0 equal to lambda 1 to the power k plus 1 C1 x1, because lambda 1 modulus value of lambda 1 is less than 1, because modulus of lambda 1 is numerically largest other lambda i's. So lambda 1 modulus value of lambda 1 is less than 1 for I is equal to 2, 3 n. So lambda 2 by lambda 1 modulus value of lambda 2 lambda 1 is less than 1. So this second term, from the second term lambda 2 by lambda 1 is less than 1, lambda n by lambda 1 whole to the power k is less than 1, and similarly this. And if k up to large value, so this second term, from the second term these values are very small, so we get a to the power k x0 equal to lambda 1 to the power k C1 x1 and a to the power k plus 1 x0 equal to lambda 1 to the power k plus 1 C1 x1, and other terms can be cancelled due to the numerically largest the eigenvalue lambda 1. So ultimately we get for k tends to infinity these equations 5 and equation 6. And so lambda I by lambda 1 to the power k tends to 0 and lambda I by lambda 1 to the power k plus 1 tends to 0 as k tends to infinity. Taking dot product of both sides of 5 and 6, and we get with any y vector y which is not orthogonal to capital X1, we have for k tends to infinity, we get from the 5 and 6, notice that from 5 and equation this 5 and equation 6, then we get a to the power k x0 multiplying product dot product the y vector lambda 1 to the power k C1 x1 dot y. So we can write from this C1 x1 y equal to a to the power k x0 y dot y by lambda 1 to the power k, and similarly a to the power k plus 1 x0 dot y equal to lambda 1 to the power k plus 1 C1 x1 dot y, and so C1 x1 dot y equal to a to the power k plus 1 x0 dot y. And so a to the power k x0 dot y by lambda 1 to the power k equal to these both sides, this C1 x1 dot y and this side is C1 x1 dot y. So this quantity from the left hand side quantity and this the quantity also equal. So this and this are also are equal. So a to the power k x0 dot y and lambda 1 to the power k equal to a to the power k plus 1 x0 dot y by lambda 1 to the power k plus 1, both are equal and both are not equal to 0. And so a to the power k x0 dot y by a to the power k x0 dot y equal to lambda 1 to the power k plus 1 by lambda 1 to the power k. So cancel lambda 1 to the power k, we get lambda 1. So this is the numerically largest eigenvalue, lambda 1. So from this expression we get this lambda 1, numerically largest eigenvalue lambda 1 is equal to a to the power k plus 1 x0 dot y by a to the power k x0 dot y. If we choose y equal to a to the power k x0, then from this equation a to the power k plus 1 x0 dot a to the power k x0 by a to the power k x0 dot a to the power k x0, capital Y is any arbitrary vector other than this condition, only condition hold this, which is not orthogonal to x1. This is the condition. So we choose y capital Y equal to the power k x0 and multiply dot product, taking dot product of this, and this is the a to the power k x0 dot a to the power k x0 by a to the power k x0 dot a to the power k x0 as k tends to infinity. Now for any eigenpair means this lambda 1 is the eigenvalue and v is the corresponding eigenvector. That's called eigenpair for the matrix A. So lambda 1 is the eigenvalue and corresponding eigenvector is v. So we have this a v equal to lambda 1 v, and taking dot product with the both sides on v with v. So av dot v equal to lambda 1 v dot v. So lambda 1 equal to av dot v by v dot v. Here dot means the dot product, vector dot product. Expression 8 matches with the 7 when v is equal to a to the power k x0. Obviously this 8 equation, expression 8 and expression 7 equal, both equal if we choose v equal to a to the power k x0. Hence a to the power k x0 is an eigenvector corresponding to the eigenvalue lambda 1. The power of A give the power method its name. So this name is the power method due to the power of the A, this a to the power k x0, this is the power of A. So this is called the power method. Now the practical procedure is that if modulus of lambda 2 less than modulus of lambda 1, then the faster convergence is obtained. In order to keep the round of error in control, we normalize such that the largest element is unity. It is clear from a practical example. The vector before the pre-multiplying by a, we can write the method as follows. Let capital X0, this notation X0 notation means this is the iteration, initial approximation. This x vector initial approximation, b x0 be non-zero arbitrary initial vector. You can choose this x is 1 1 1 or 1 0 0 or 0 1 0 or 0 0 1, but not 0 0 0 for matrix 3 by 3 matrix, or not non-orthogonal to capital X1. To find that y k plus 1 iteration for the y k plus 1 iteration equal to x a into x k iteration, and x k plus 1 iteration this equal to y k plus 1 by m to the power k plus 1. K runs from 0 1 2 and so on, where mk plus 1 iteration is the largest element in magnitude of yk plus 1. Then lambda 1 is equal to limit k tends to infinity m value of k iteration. And the corresponding eigenvector is that v1 is equal to limit k tends to infinity x for k iteration. This is the practical procedure, but it is not clear until we discuss through a practical example. We now discuss the practical example, but before that we discuss when power method fail. If matrix A, square matrix A is not diagonalizable, that is when number of linearly independent eigenvectors is less than n. This is the very important condition. The number of linearly independent eigenvectors, if order of the matrix A, square matrix A is n, then there must be exist exactly in linearly independent eigenvectors. and A does not have a dominant eigenvalue, then we when the dominant eigenvalue is thus that modulus of lambda 1 greater than modulus of lambda 2. So at least one of the eigenvalue must be dominant other eigenvalues from the other eigenvalues. Must one eigenvalue, numerical value of this that eigenvalue must be greater than the other eigenvalues. So this is the dominant or largest eigenvalue numerically. The entries of the matrix A contains significant errors. Mth power of A, that is A to the power m, will have significant round of error in their entries. Now go through the practical example. Find the absolutely sorry, this is the smallest eigenvalue. So we later go through the later example. We come to the largest eigenvalue example here. Am I audible? Hello? আমার কথা শুনতে পাচ্ছো? First we consider this example. Determine the numerically largest eigenvalue and corresponding eigenvector of the matrix A. 1, 3, minus 1, 3, 2, 4, minus 1, 4, 10. This is the square matrix of order 3. First এই অঙ্কটা ভালো করে বোঝার চেষ্টা করো, তবে তুমি প্র্যাকটিক্যালটা বুঝতে পারবে কিভাবে প্র্যাকটিক্যালটা হচ্ছে। ফার্স্ট আমরা ইনিশিয়ালাইজ করছি একটা ভেক্টর u0 দিয়ে 1 1 1, যেখানে আমরা থিওরিতে যেটাকে আমরা x0 বলেছিলাম, x0 ইনিশিয়াল অ্যাপ্রক্সিমেশন অফ x0 বলেছিলাম, সেটা 1 1 1 চুজ করতে পারো, 1 0 0 or 0 1 0 or 0 0 1, but u0 cannot be chosen 0 0 0. All three elements are 0 because u0 is non-zero matrix, non-zero non-null vector. Then v1 is the A equal to A into u0, this A matrix in the and you multiply with the column vector A1 1 1 u0. So multiply this, and so this 3 by 3 and 3 by 1. So this is the 3 by 1 column vector. We get column vector v1. This is the v1, 3 9 13. Here the largest value is numerical largest value is 13. If there is a minus 13, so take common minus 13 such that this we get 1 is the largest value. 1 is the largest value here. So if there is minus 13, so take common minus 13 and we get at least 1, and other elements are the less than 1. Clear? So v1 is this, multiplying this 13, then v1 is equal to 13 into u1, then v2 equal to A into u1. So A matrix A is given matrix, and u1 is this vector u1, this 13 into u1, this vector is u1. So post multiplying A by u1, the u1 is this from this vector, and multiplying we get the result this. And here the numerical largest value is 12 point something, so take common 12.53 and we get this, and this the 12.5387 into u2, called this column vector is called u2. So v2 equal to this 12 point something into u2. Next approximation v3 equal to A into u2. A is the given matrix, and post multiplying by u2, and u2 you can get the u2 from the previous calculation. This is the u2 column vector u2, and post multiplying with A, this we get 11.83455, and this called u3. So we get v3 is equal to 11.83 into u3, and continuing in this way we get and v4 v5 v6, and notice that this 11.73 11.68 11.66 11.66, so we get v6 and v7, we get this is the convergent up to 2 decimal places. 11.66, this is the numerically largest eigenvalue. This 11.66 and 11.66, and corresponding eigenvector is u7 or u6 are same also, nearly approximately equal to this. So u6 and u7, notice that u6 is 0.02 0.0251, 0.42251 and 1 and 0.421 and 1. So U6 and U7 are also nearly equal, corresponding element are nearly equal, and this 11.66 and this for V7 11.66 is also nearly equal. So U6 nearly equal to U7, correct up to 3 significant figures. The largest eigenvalue is 11.66, numerically largest eigenvalue, correct to 4 significant figures. And the corresponding eigenvector is this 0.02514 and 0.1, and this is the corresponding eigenvector. And this 11.66, the numerically largest eigenvalue, and the corresponding eigenvector, this is called the eigenpair, largest eigenpair, but dominant eigenpair. Clear?
Yes, sir.
Now we go to the practical example. So consider this C programming for the numerically largest eigenvalue by power method. So this is the এটা আমরা তোমাদের এতে পাঠিয়ে দিয়েছি, হোয়াটসঅ্যাপে পাঠিয়ে দিয়েছি, একবার দেখে নাও, চেক করে নাও। হোয়াটসঅ্যাপে পাঠিয়েছি। আমরা প্রথমে আমরা
ম্যাট্রিক্সটাকে পুট করতে, ফার্স্টে অর্ডারটা চাইছে, তারপর ম্যাট্রিক্সটা পুট করতে।
হ্যাঁ হ্যাঁ, প্রথমে ম্যাট্রিক্সের এই সাইজ আমরা ডিফাইন করে নিয়েছি। সাইজটাকে আমরা বলে দিচ্ছি ডিফাইন, নোটিস দ্যাট হিয়ার হ্যাজ ডিফাইন সাইজ 200. 200 is the dimension of this. A is the matrix dimension 2 by 2 matrix, X is dimension 1 dimensional array, Z, ZZ and NZ, E, T, Z max, Z min, E max are the variable, all variable double size variable. I, J, N, K are the integer variable, and now first we enter the order of the matrix, and we get the enter the matrix element row wise, a11, a12, a13 and so on, and we get this for this. Now this is the practical number 25. Practical number 25. Write an efficient computer programming in C or Fortran. You write only C. Cut this in Fortran to compute the dominant eigenpair, largest eigenvalue and corresponding eigenvector of the following matrix, correct to 6 significant figures by the power method. This is the practical problem. 8.47 plus r plus 1 by 10 minus 1.15, and this and this is the r is the last digit of your roll number, and put this and run this program, and this is the
উপরে তুলুন।
হ্যাঁ, তোমরা এই একটু ম্যাট্রিক্সটা একটু এন্ট্রি করে নাও, তো এন্ট্রি করে নিয়ে আমাকে বলো তো, আমি এবার প্রোগ্রামটা রান করব। তোমরা একটু এন্ট্রি করে নাও ম্যাট্রিক্সটাকে। 8.47 প্লাস
ম্যাট্রিক্সটা এন্ট্রি করে নিয়েছি স্যার, উপরের হেডিংটা শুধু একবার দেখবো, হেডিংটা দেখো।
হেডিংটা আমি তোমাদের হোয়াটসঅ্যাপ গ্রুপে পাঠিয়ে দেবো।
আচ্ছা আচ্ছা,
হ্যাঁ, তোমরা শুধু ম্যাট্রিক্সটা এন্ট্রি করো, আমি প্রোগ্রামটা রান করাবো, তোমরা আমাকে একটু হেল্প করবে। হ্যাঁ, আর এর মানটা, আর তোমার আর কত, আর কত আর ভ্যালু 3, তাহলে ওইটা ক্যালকুলেট করে আমাকে বলো এই ফার্স্ট এলিমেন্টটা কত হয়েছে। এই আমরা রো ওয়াইজ পুট করবো, রো ওয়াইজ পুট করবো আমরা ম্যাট্রিক্সের ভ্যালুগুলো, আর ভ্যালুগুলো ক্যালকুলেট করে নাও। ক্যালকুলেট করে নিয়ে আমাকে রো ওয়াইজ পুট করবো আমরা এই প্রোগ্রামিংটায়। আমরা দেখবো প্রোগ্রামটা রান করছে কিনা, ঠিকঠাক রান করছে কিনা। করে নিয়েছো, ক্যালকুলেশন করে নিয়েছো, আমি কল করবো। প্রথমে আমরা এটাকে রিড করছি। ফর I is equal to j, I is equal to 1 to n, j is equal to 1 to n, দ্যাটস মিনস দ্য রো ওয়াইজ রিড করছি আমরা ম্যাট্রিক্সটাকে। তারপরে ওই কলাম ভেক্টর পুট করছি, অর্থাৎ ওই u0 1 1 1 1 0 0 or 0 1 0 নন জিরো, এন্টার দ্য নন জিরো কলাম ভেক্টর। দিস ইজ দ্য নন জিরো কলাম ভেক্টর, নন জিরো column vector, non-zero column vector, order or same order. This is the non-zero column vector, the size this, and print the iteration for this stored z in nz for rearranging the elements. We calculate this, rearranging this to arrange the elements ax in ascending order. and this then to choose the numerically largest element of Ax. So A absolute value of Z minimum is greater than equal to A absolute of Z maximum. So Z max equal to Z minimum, and we ultimately this up to correct up to 6 decimal places. 1 2 3 4 5 6 7. This is the 6 decimal places. So we run this. হ্যাঁ বলো, ম্যাট্রিক্সের সাইজটা কত ছিল?
অর্ডারটা 4।
4, দাঁড়াও একটু আসতে দাও ওটাকে। এক্সিকিউট করতে একটু সময় লাগছে। ম্যাট্রিক্সের অর্ডার 4। 4 A11।
স্যার 8টা বসিয়ে ক্যালকুলেট করার পর বলবো তো?
হ্যাঁ হ্যাঁ ওইটাই বলবে।
8.87।
8.87, সরি না, 8.87 12,
মানে কলাম ওয়াইজ বলবো?
না রো ওয়াইজ।
আচ্ছা, রো ওয়াইজ। -1.15।
-1.15, 13,
1.55।
1.55, 14,
-3.12।
-3.12. Next column, next row, 21,
-1.15।
-1.15. Next, 22,
15.76। 5.76।
5.76. Next, 23,
-3.14।
3.14,
-3.14 স্যার।
-3.14. Next, 24,
2.45।
2.45, 31,
1.55।
1.55, 32,
-3.14।
-3.14, 33,
8.67।
8.67, 34,
-1.18।
-1.18. আচ্ছা, এবার আমরা পুট করছি ও 41, ও লাস্ট লাস্ট রোটা 41টা।
ইয়েস স্যার। -3.12।
-3.12,
12।
42,
2.45।
2.45, 43,
-1.18।
-1.18, 44,
9.25।
9.25. Enter the non-zero column vector x1, column vector 1 1, any you can choose 1 1 1 1 1 1, চারটে 1 যোগ করতে হবে। 1 0 0, we put here 1, sorry, 1 0 0, sorry, 0 0 1 0 0, we put here this. Required eigenvalue is 18.508, and eigenvector is this. So we check this answer. R equal to
3 স্যার।
3. R equal to 3.
18.5082।
R equal to 3.
Yes.
18.5082. Correct answer. And record eigenvector minus 32
5760
sorry, -32571 minus 0.4218, 0.42817574. Answer is correct. So this is the problem, but this সি প্রোগ্রামিংটা বোঝা কিন্তু বেশ শক্ত আছে, এটাকে খুব ভালোভাবে বুঝতে হবে। প্রোগ্রামিংটা বেশ বড় এবং খুব শক্ত প্রোগ্রামিং, নিজে নিজে করা খুব শক্ত, লজিকগুলোকে বোঝাও চেষ্টা করাটা খুব শক্ত আছে। এটাকে নিজেকে বোঝার চেষ্টা করো, এটাকে বেশ বড় লেংদি
আচ্ছা, ওটা
প্রোগ্রামিং।
দেখতে হবে। আর ভাবছি ম্যাট্রিক্সটাকে পুট করে দেবো একেবারে, তাহলে যদি একটু
তাহলে
হবে, নাহলে আমাকে
হ্যাঁ,
পড়াতে হবে।
এবং এই প্রত্যেকটা স্টেপ বোঝার আছে, এই কীভাবে তোমার এই ফ্লোচারটা হচ্ছে, ইম্যাক্সটা কাকে বলা হচ্ছে না হচ্ছে, এগুলো স্টেপগুলো খুব বোঝার আছে। এই জিনিসগুলো এগুলো তোমাকে দেখতে হবে, খুঁটিয়ে খুঁটিয়ে প্রত্যেকটা স্টেপ খুঁটিয়ে খুঁটিয়ে দেখতে হবে। এই লাস্ট স্টেপগুলো যেগুলো ডবল স্ল্যাশ দেওয়া আছে ওগুলোকে অফ করে দেবে, ওগুলো দরকার নেই। ঠিক আছে, ওকে।